Transforming parabolas. We're going to begin by just defining family of graphs. So this entire lesson is all about taking parabolas on the coordinate board and transforming them. So that means moving them left, right, up, or down. So we're going to be moving parabolas today all around this coordinate board, left, right, up, down. We're going to be stretching and shrinking them. So I'm continually going to be referring to the fact that these parabolas move the same way that our absolute value functions did. So when we moved our absolute value functions around, left, right, up, down, and stretched and shrunk them, these parabolas do exactly the same thing. They're just a different shape. So we're going to continually be talking about that. So a family of graphs are variations to the parent graph. Okay, variations to the parent graph. So we're taking the parent graph, x squared, and we're going to be moving it up, down, left, and right. How do we make those variations to the parent graph? We do changes in size and or position. Okay, so we're going to move them left, right, up, down, and then we're going to stretch and shrink them. So changes in their size and or in their position. So here is my parent graph, f of x equals x squared, okay? And we know that the parent graph starts at 0, 0. And if I were to get values at -2, if I did -2 squared, that would give me +4. So at -2, I'm at +4. At -1, if I squared -1, I would get +1. 0 squared is 0. 1 squared is 1. You can see we're mirroring our graph. Okay, so at 2, we're up at 4. So this is our parent graph, normal shape. We've talked about this a few times, the fact that the first point away is usually pretty close to the vertex. They usually form this triangle when they're not stretched or shrunk. And then the very next one is over 2, up 4, then over 3, up 9, because we're squaring the 3. And so we could also add that if we wanted to, knowing that when you plug in a point and you square it and you plot it, you can mirror it over because there's an axis of symmetry right down the center of our parabola. So there's my axis of symmetry. So here is my parabola. Wow, this is really tough to do on this pen. So there's our parabola, okay? That's the parent graph. So all of them should have this shape unless we stretch or shrink them. And this is the form that we're going to use, the vertex form we call it, because we can easily find our vertex. We talked about how now we're going to use HK to represent the vertex of our parabola. And so this is our vertex form. We'll work with that a little bit as we go. So a couple of things we need to know first about this parent graph. The first change we're going to talk about is the direction. And when I say the direction, I mean which way it opens. Okay, so we're going to talk about, does it open up or does it open down? I think most of us already know that, so I'm just going to clear the screen, move the page, and we're going to talk about the direction. So we have two options right now if A is positive, and remember that A is the number in front of the x squared term. This is where we find ax squared. If A is 1, like in this case, then it's positive. And if it's positive or greater than 0, then it's going to open up. Okay, so when A is positive, it's going to open up. So my graph's going to be here, 2, 4, 3, 9. Knowing it's just the normal shape, I can just very easily plot my points. Okay, and so it's going to open upward. There we go. When A, again, this is where we find our A. Remember, it's ax squared, so A is the number in front of the x squared term. When A is negative, then it's going to open down. And we've talked about that several times now, so I know that you're comfortable with that. Now remember, when you go to graph that, it's going to have exactly the same shape as this one, except that it's going to be in the reverse order, so it's going to be upside down. So normally we go, when it's 1, we go to 1. When it's 2, we go to 4. When it's 3, we go to 9. The only difference is this time, instead of going over 1, up 1, we're going to go over 1, down 1, because it's going to be opening downward. So when it opens downward, we're taking the opposite of all of these, right? The opposite of x squared. So we squared it, we got 1. Now I need to take the opposite and get -1. When I square the 4, I'm going to take the opposite, -4, opposite, -9. So it's just telling you that instead of going up 1, we're going to go down 1, and over 2, down 4, over 3, down 9, and we're still going to mirror it because it's still a symmetrical object, right? So we're still going to mirror it over, but this time it's just going to go downward. So it's going to look like that. Same shape, just down. All right. On to the next page where we're going to talk about the shape of the figures. And again, this is the trickiest part, the shape part, because you can't just go by its normal shape. We're going to actually have to do some calculating here to see what happens with these shapes, okay? So if a is greater than 1, like in this case, a is greater than 1, we're pulling it upward. So it's twice, whoops, definitely wanted that to say twice. Okay, so it's twice as tall as it was before. So we're going to just plot some points just to see what happens when we do 2x squared, okay? So I'm going to do -2. So we have to do the squared part first, remember, according to Dear Aunt Sally and our order of operations. So we're going to square 2. -2 times -2 is +4, and 4 times 2 gives me 8. So at -2, I'm now at +8. -1. So again, we have to square the -1 first. That gives me a +1 times 2 gives me 2. So at -1, I'm now up 2. At 0, I'm still going to be at 0. Okay, so you can see the parent graph. If I were to post the parent graph, and I'll do that in a different color so it doesn't get too confusing, the parent graph would be here at 0, 0. It'd be at 1, and then it would be at 2, 4, and then it would be at 3, 9. So this is where my parent graph would have been. And you can see that I've stretched it. It's now going to be much thinner. So if this is where my parent graph was supposed to be, I'll try to do this as accurately as I can. It's hard drawing with this little thing. Okay, so that's the parent. And you don't need to draw the parent on your graph if you don't want to. A lot of students like it for comparison. Okay, so the graph we're drawing, 1 is up 2, and then 2 is up to 8. You can see it's much more stretched out. Okay, so this is the one we drew. This is 2x squared. So it's twice as tall as the parent. We've stretched it out, okay? In the second picture, we're now doing 1/3 of the parent function. So now it's only 1/3 as high or as tall. So now it's going to be 1/3 of its original height. So again, I'm just going to put the parent on here, original, over 1 up 1, over 2 up 4, over 3 up 9. And then mirror it over here, just so we have it to refer to. So this is the parent function. Okay. And now let's just talk about, again, what happens when we do 1/3 of x squared. Now, some of these are not going to fit on the graph, so let's just talk about this. Anytime there's a fraction in front, you want to try to choose numbers that are going to be divisible by 3 that you're going to plug in. So I'm going to do 0, 3, 6. So at 0, I'm going to still be at 0, right? So I'm going to square that, and I'm going to get 0. So 0, 0. Let me do it in a different color. I'll do my graph in a second in a different color. And then I'm going to do 1/3 of 3 squared. 3 times 3 is 9. 1/3 of 9, or 9 divided by 3 is 3. And then I'm going to do 6 squared is 36, and 36 divided by 3 is 12. So if I were to graph that, and if I were using bigger graph paper, I would see 0, and then over to 3, I'm up to 3. And then at 6, I'm way over here. I'm going to be way up here at 12. So like up here somewhere. Okay. And if I were to plug in 1 just for fun, I want you to see what happens when we plug in 1. Right? I'm going to square it, and times 1/3, I'm going to get 1/3. So normally when we plug in 1, we get 1 in the parent graph, right? Over 1, up 1 parent graph. This time I'm going to go over 1, up 1/3. So 1/3 of a box. You can see it's very flattened out. Whoops, I missed. So over 1, up 1/3 as high, and then 3, -3, 3, and then -6, I would be way up here at 12. So it's 1/3 as tall as it was before. You can see we're flattening it down, kind of squishing it a little bit. So the part I really want you to think about is that first set of points. Instead of over 1, up 1, if this were my first box, I would be going over 1, up 1/3, and you can see how it's only 1/3 of its original height at that 1 box. And then over here, same deal. If you think about how it starts first box, right? It's usually over 1, up 1. This time it was over 1, up 2. So it's twice as tall as its original. So twice as tall, and this one's 1/3 as tall. Okay. These are the hardest ones to do, the shape ones. The vertical movement and horizontal movement, I think you'll find pretty easy. So let's move on to those. Clear the page, scroll. Whoops. So vertical movement, again, think back to your absolute value functions, okay? So in the absolute value functions, the vertical movement, vertical being up and down. Remember, for our absolute value functions, we did plus or minus k. Positive was up and negative was down. This is exactly the same thing. So if k is positive, so notice this is outside, this is our plus k. If it's positive, we're going to go up 2. So up 2, and we're going to put our parent graph there. So remember, it's over 1, up 1, and we do it right here. This is our shape. Over 2, up 1, 2, 3, 4, and we'll mirror that over. And then we did over 1, 2, 3, up 1, 2, 3, 4, 5, 6, 7, 8, 9 would put us right here. And so we've taken our parent graph and we've moved it up 2. So it kept the same shape, we just shifted it up 2 units on the y. When k is negative, so this is minus k, we're going to move down. So when it was positive, we went up, negative's going down. So I'm going to go down 3. So I'm taking my parent function and I'm moving it down 3. Still is going to keep the same shape, over 1, up 1, over 2, up 1, 2, 3, 4, mirror it over. Over 3, 1, 2, 3, up 1, 2, 3, 4, 5, 6, 7, 8, and 9. Mirror it over. And we have our parent function down 3. So vertical movement, pretty self-explanatory. It's always that number at the end of your function, and that's the one that tells you up or down. Okay, next page, horizontal movement. Okay, so this is our left-right movement. Same thing again as the absolute value functions. We had plus or minus h inside the absolute value symbols. And this was positive, we moved left. Remember, we did the opposite. And negative, we moved right. That's going to be exactly the same thing, except it's in parentheses with a square on the outside, because we're taking the x squared term and then we're going to add or subtract something from it. So negative means go right. So I'm going to go right 2. So I'm going to take my parent function and literally just move it over 2 units to the right. It's going to keep the same, again, shape, over 1, up 1, over 2, up 1, 2, 3, 4, and then 5, 6, 7, 8, over 3, up 9. So here's my, whoops, I went over too many with that one. Hang on. 9 is right here. So there's my parent function, just moved over to the right 2 units. And then positive means that I'm going to move left. So I'm going left 3. Backward 3 keeps the same shape. Over 2 up 4. And then over 3 up 5, 6, 7, 8, 9. Again, parent function, normal shape, just shifted left 3. Okay? So just to very quickly review, I'm going to move the page again just a tad. We have what each of these terms tells us. So the A in the front, if it is positive, tells us that it opens up. Okay? If the A in the front is negative, it tells us that it opens down. The other thing that it tells us is shape, the A does. So when A is greater than 1, we're stretching it, right? So it's going to be twice as tall, 3 times as tall. When A is between 0 and 1, then it is a fraction, and then it's going to be a shrink. It's going to be a third of its height or half of its height. So A gives us a lot of information about which way it opens and which shape it is. H tells us our horizontal movement, so left or right. If it's positive, we move left, and if it's negative, we move right. So that is on the x-axis, remember, because it's left or right. That's tricky. We do the opposite of what's inside of the parentheses. And then the K tells us up or down, and up is positive and down is negative. And again, that's on the y-axis because that's the vertical change. So you need to understand what each of those means so that you're able to combine them. Sometimes we'll have just one thing happening. Sometimes you'll have multiple things happening. But the idea is that you know what each of these numbers tells you to do.